Saturn is not peaceful. It is a violent colossus wearing the most beautiful disguise in the solar system, and for nearly 20 years, NASA had a spacecraft close enough to see through the costume. Cassini wasn't just visiting Saturn, it was living there. From 2004 until its deliberate destruction in 2017, it orbited the planet, dove between the rings, skimmed the moons, and sent back data so strange that scientists are still untangling it almost a decade after the mission ended. Some of what it found doesn't fit any of the models we had. Some of what it found shouldn't exist. And one thing it found, hidden under the ice of a tiny moon nobody used to care about, might be the most important discovery in the history of planetary science. We'll come back to that. First, you need to understand what Cassini saw when it actually touched Saturn for the last time. On September 15, 2017, NASA pointed Cassini into Saturn's atmosphere and told it to keep transmitting until it couldn't anymore. The spacecraft had run out of fuel for steering, and rather than risk it crashing into one of the moons and contaminating a place that might harbor life, the team chose to end it on their terms. The probe hit the top of the atmosphere about 1,200 miles above the cloud tops, moving at roughly 70,000 miles per hour, screaming straight down into the thickening haze. Its thrusters fired at full power for 91 seconds, fighting to keep the antenna pointed at Earth. It transmitted the entire time. Then, the atmosphere tipped it backward, the signal cut out, and Saturn finished what it had started. But Cassini got something done in those final seconds, and in the years of close passes leading up to the dive, it had already touched Saturn in ways no spacecraft ever had before. The results forced a quiet revolution in what we thought we knew about every gas giant in the universe. Saturn's rings are dying. Not slowly, not over geological timescales, but visibly, measurably, on a clock that runs in human lifetimes. Cassini's instruments detected a steady rain of ring material falling into the planet, a phenomenon scientists now call ring rain. About 22,000 pounds of ice and dust drop out of the rings into Saturn's atmosphere every second. That is not a typo. Every second, roughly the weight of a fully loaded school bus is being pulled out of the rings by Saturn's gravity and consumed. At that rate, the rings have somewhere between 100 million and 300 million years left. In cosmic terms, that's nothing. Saturn has been orbiting the Sun for about 4.5 billion years, and yet for most of that history, it probably looked like a plain beige gas giant with no rings at all. The rings, the single most iconic feature of any planet in our solar system, are a temporary decoration. We are watching them fall apart in real time. The strangest part is the rings' age. Cassini's data suggests they're young, maybe 100 to 400 million years old, which means dinosaurs probably went extinct without ever seeing a ringed Saturn. The rings appeared, in the geological blink of an eye, from the scattered guts of a moon that didn't survive. Something, possibly a comet, possibly a wayward icy body, drifted too close to Saturn and got pulled apart by tidal forces. The debris spread out into a flat disk. That disk became the rings, and now Saturn is finishing what it started, eating the evidence of the crime 1 ton at a time. Cassini found something else in those final orbits that should not have been possible. Between April and September of 2017, the spacecraft made 22 dives through the gap between Saturn and the innermost ring, a region only about 1,200 miles wide. That's roughly the distance from Chicago to Denver. Cassini was threading a needle at 76,000 miles per hour. And in that gap, scientists expected to find a region thick with dust and debris. The models said there had to be material there. The gap was almost empty. Nobody had a clean answer for why. The space between the planet and its rings, the most natural place for orbiting debris to collect, was clearer than the surrounding rings by a factor that broke the models. Engineers had built Cassini's final orbits, assuming it would need to take impacts from ring particles. Instead, the probe sailed through silence. Why the gap was empty is still being debated. The dominant idea is that Saturn's intense gravity and electromagnetic environment sweep it clean. A competing view holds that the gap is a relatively new feature created by some process we don't fully understand. Either way, Cassini had to die because we don't know what we don't know. And while it was diving through that strange, silent corridor, it was also feeling Saturn's atmosphere directly for the first time. The outermost layer extends much farther than anyone thought. Cassini measured significant atmospheric drag at altitudes where there was supposed to be only vacuum. Saturn is bigger than we knew, not in terms of its visible cloud tops, but in terms of where its atmosphere actually begins to interact with the space around it. The planet has an invisible halo of gas reaching out hundreds of thousands of miles into the dark. The other thing those final orbits revealed was something called the ring length of day problem. For decades, scientists thought they knew how fast Saturn rotated. Voyager had measured the planet's day at about 10 hours and 39 minutes back in the 1980s. Then Cassini arrived and measured it again. The number was different. Worse, it kept changing depending on which method was used. Saturn appeared to be rotating at different speeds in different parts of the magnetosphere, which made no sense for a single rigid body. It took years of Cassini data to finally crack the problem. The answer came in 2019, 2 years after the spacecraft was already gone. By analyzing waves in the rings, the kind of subtle ripples created by the planet's internal vibrations, scientists clocked Saturn's true day at 10 hours, 33 minutes, and 38 seconds. The rings were used as a seismograph. The planet's own jewelry told us how fast it was spinning. So, when we say Cassini touched Saturn, we mean it. It scraped through the outer skin of the planet half a dozen times before the final plunge. Each pass yielded data on the composition of that upper atmosphere. Mostly hydrogen, mostly helium, with traces of methane, ammonia, and a chemistry scientists are still mapping. The gas giant is not a uniform ball. It has layers, currents, and chemistry that varies by altitude in ways that defy our experience of Earth's atmosphere. Now, zoom in on the cloud tops, because what's happening up there makes Earth's worst hurricanes look like a light breeze. Saturn has a permanent storm at its north pole. Not occasional, not seasonal, permanent. And it's not a circle, it's a hexagon, a six-sided storm with sides about 9,000 miles long, each one longer than the diameter of Earth, rotating in place at the top of the planet. Voyager first photographed it in the 1980s. Cassini watched it for over a decade. It has not moved, it has not changed shape. A hurricane on Earth is a chaotic, swirling mess that lives and dies in days. The hexagon at Saturn's North Pole has been there for at least the entire history of human observation, and probably much longer. Inside the hexagon, the wind speeds reach about 220 miles per hour. That's the strength of an EF5 tornado, the most violent class on Earth's scale. Except this tornado is the size of 2 Earths stacked side by side, and it has been spinning continuously for centuries that we know of. How does a six-sided storm hold its shape? The leading theory involves jet streams locked into resonance with the planet's rotation, creating a stable wave pattern with exactly 6 peaks. Laboratory experiments with rotating fluids have actually reproduced the hexagonal shape, which is the kind of explanation that sounds wrong until you see the math. Geometry, it turns out, can be a force of nature. Saturn is showing us what happens when fluid dynamics scale up to the size of a world. But honestly, this is the part of the story that still gets to me. Cassini didn't just see the hexagon, it saw inside it. In 2013, the spacecraft captured the first close-up images of the central eye of the hexagonal storm, a massive vortex about 50 times larger than the eye of an average Earth hurricane, with walls of cloud rising tens of miles above the surrounding atmosphere. Standing on a platform inside that eye, you would see vertical cliffs of cloud curving around you, taller than Mount Everest, lit by a sun so distant it looks like a bright pinprick. It would be the most beautiful and unsurvivable place a human could imagine. Saturn doesn't stop with the hexagon though. The whole planet is electrically charged in ways that don't match anything else in the solar system. Cassini measured giant lightning storms that dwarf anything Earth can produce. A single bolt of Saturn lightning can be 10,000 times more powerful than its Earth equivalent, releasing energy that would light up a small country. And these storms can last for months. Cassini tracked one storm that began in December 2010 as a small, bright spot and grew until it wrapped completely around the planet, a band of lightning and turbulence circling Saturn for about 200 days before it finally ran into its own tail and died. The lightning isn't random. It seems to come in cycles tied to Saturn's seasons, which last about 7.5 Earth years each. The planet has weather on a scale we don't have language for. A thunderstorm on Saturn isn't an event, it's an era. And that's just the surface, or what passes for one. Saturn doesn't have a solid surface in the way Earth does. Go down through the cloud tops and the atmosphere just keeps getting thicker, hotter, and denser. About 600 miles down, the pressure is already crushing. 2,000 miles down, the hydrogen gas around you isn't behaving like gas anymore. It's becoming liquid. Go deeper and the liquid hydrogen starts to become something stranger. Under enough pressure, hydrogen turns into a metal. It conducts electricity. It flows. Saturn's interior is an ocean of liquid metallic hydrogen swirling around a rocky core. And that swirling is what generates the planet's magnetic field. The field is enormous. Saturn's magnetosphere stretches millions of miles into space, deflecting solar radiation, capturing charged particles, and creating its own auroras at both poles. Cassini flew through this magnetosphere repeatedly and discovered it does something Earth's doesn't. Saturn's magnetic field is almost perfectly aligned with its rotation axis. That should be impossible. Every other planet with a magnetic field has it tilted at some angle. Earth's is tilted about 10 degrees. Jupiter's is about 10 degrees. Saturn's is essentially zero, less than 1/10 of a degree. As close to perfectly aligned as we can measure. Why does this matter? Because the standard theory of how planets generate magnetic fields requires a tilted, asymmetric dynamo inside. Without that asymmetry, the field shouldn't sustain itself. Saturn does it anyway, and physicists are still arguing about how. One proposal involves a thin, stable layer inside the planet, between the metallic hydrogen and the core, that smooths the field as it rises and erases the tilt before it reaches the surface. A more uncomfortable possibility is that we're misunderstanding the physics of planetary dynamos at this scale entirely. The honest answer is that Saturn is generating one of the largest magnetic fields in the solar system in a way our models say shouldn't work. Then there's the moons. Saturn has 274 confirmed moons as of the most recent count, by far the most of any planet in our solar system. Some are tiny, just rocks a few miles across. Some are bigger than the planet Mercury. And one of them is the reason Cassini was destroyed on purpose. Because if we'd let it crash anywhere it pleased, it might have hit Enceladus. And Enceladus is where the story stops being about Saturn and becomes about us. Enceladus is small, only about 313 miles across, which is roughly the distance from New York City to Pittsburgh. You could fit it inside Texas with room to spare. From a distance, it looks like a smooth white snowball, unremarkable among Saturn's larger moons. For decades, nobody paid much attention to it. Then Cassini flew close enough to see what was actually happening on its surface, and the textbooks had to be rewritten again. In 2005, Cassini detected something coming off the south pole of Enceladus: plumes. Geysers of water vapor and ice, jetting hundreds of miles into space at about 800 miles per hour, faster than the speed of sound. The moon was alive. Something underneath the surface was driving water up through cracks in the ice and shooting it into the void. Over the following years, Cassini flew through those plumes, directly through them. The spacecraft tasted Enceladus. The instruments analyzed the chemistry of the water vapor and ice grains. They found water. They found salt. They found organic molecules, the carbon-based building blocks that life on Earth is made from. They found molecular hydrogen, which on Earth is a key fuel source for certain microbes living near deep ocean hydrothermal vents. They found silica particles, the kind that form when hot rock meets liquid water at temperatures around 200 degrees Fahrenheit, which meant something inside Enceladus was hot enough to cook minerals into rocks at the bottom of an ocean. Yes, an ocean. Beneath the ice shell of Enceladus, there is a global ocean of liquid water, about 6 miles deep, with a total volume only a fraction of Earth's oceans, but covering the entire moon and in direct contact with a rocky seafloor. Warm enough to be liquid, salty, chemically active, with energy sources at the bottom that resemble exactly the kind of environment where life first emerged on Earth, near hydrothermal vents in the deep Pacific. We have, in our own solar system, a tiny moon that has every ingredient we know of for life: water, energy, organic chemistry, time, because the ocean has probably existed for hundreds of millions of years at least. We didn't have to leave the neighborhood. The conditions for life, the same conditions we think gave rise to life on Earth, are sitting in the dark under more than 10 miles of ice, in a place where the sun is barely brighter than a distant star. Cassini didn't find life. Let me be clear about that. The instruments weren't designed to detect microbes directly. What it found was the chemistry that suggests life is possible. And every additional flight through the plumes added more evidence that the suggestion is serious. The 2017 discovery of molecular hydrogen was the moment when most planetary scientists shifted from "Enceladus might be habitable" to "Enceladus has all the requirements for habitability, and we need to go back." The mission to go back is already being planned. NASA and the European Space Agency are developing concepts for a spacecraft that would either fly through the plumes with better instruments, capable of directly detecting biological molecules, or land on the surface and sample the ice. The current best estimate is that such a mission could launch sometime in the 2030s, and we might know within our lifetimes whether anything is swimming under that ice. And Enceladus isn't the only candidate. Cassini also studied Titan, Saturn's largest moon, which is bigger than the planet Mercury. Titan has a thick atmosphere, the only moon in the solar system that does. The atmosphere is mostly nitrogen, like Earth's, but the surface is covered in lakes and rivers of liquid methane and ethane, at temperatures around -290 degrees Fahrenheit. That's colder than the lowest temperature ever recorded on Earth, by more than 160 degrees. Cassini deployed a small probe called Huygens that descended through Titan's atmosphere in 2005 and landed on the surface. It transmitted from the ground for over an hour before its batteries died. The images it sent back showed a landscape that looked eerily familiar. Riverbeds, rounded stones, shorelines, except none of it was carved by water. The riverbeds were cut by liquid methane. The stones were made of water ice as hard as granite at those temperatures. The shorelines were the edges of lakes filled with liquid natural gas. Titan is an Earth-shaped world running on the wrong fluids. And whether life could exist using methane the way Earth life uses water is one of the great open questions in biology. Some chemists argue it's possible in principle. Others argue it would be too slow, too inefficient. We don't know. NASA is sending a quadcopter drone called Dragonfly to Titan in 2028 to start finding out. It will fly between locations, scoop up samples, and analyze the chemistry of a world where the rain is gasoline and the rocks are ice. There's another Saturn moon Cassini studied that deserves its own moment, because the discovery is just plain strange. Iapetus is the third largest moon in the Saturn system, about 914 miles across, roughly the distance from Boston to Atlanta. It was discovered back in 1671 by an astronomer named Giovanni Cassini, the same Cassini the spacecraft was named after. And from the moment he found it, he noticed something was wrong. The moon was bright on one side and almost black on the other. Two completely different surfaces stuck together. For 333 years, nobody could explain it. Then the modern Cassini arrived. It flew within about 1,000 miles of Iapetus in 2007, and finally got the close look that had been waiting for 3 centuries. The moon's surface is split because Iapetus is locked in a tidal embrace with Saturn. Like our own moon, it always shows the same face to its planet, which means it also always plows through space the same way. One side is leading, slamming into dust and debris like a windshield catching bugs on a highway. That side gets coated in dark material. The other side stays clean. Over millions of years, the dark dust absorbs more heat from the sun. The ice underneath sublimates away and migrates to the colder side, making the bright side even brighter and the dark side even darker. A runaway feedback loop, painted across a moon, visible from Earth. And then Cassini photographed something else on Iapetus that nobody saw coming. A ridge of mountains running almost exactly along the moon's equator, about 800 miles long, with peaks reaching over 12 miles high. That's more than twice the height of Mount Everest, on a moon less than 1,000 miles across. The ridge stretches across most of the equatorial circumference and has no obvious cause. One theory says Iapetus once had its own ring system that collapsed and welded itself to the surface. A competing idea is that the moon spun much faster in its early history, and the ridge is the frozen remnant of a long-ago bulge at its equator. Neither has been confirmed. Iapetus is a moon with mountains taller than anything on Earth, draped across an equator nobody can explain, painted in 2 colors that were a mystery for 3 centuries until a spacecraft named after the same man who first saw the puzzle came back to solve it. So when NASA touched Saturn, what they really touched was a system that's bigger and stranger than the picture we had. Not just a beautiful ringed planet, but a violent gas giant losing its decorations, surrounded by hundreds of moons, 2 of which might be the most important places in the solar system besides Earth itself. The rings are temporary. The hexagon is permanent. The magnetic field is impossible. The plumes of Enceladus carry water from an ocean that might harbor life. The lakes of Titan are filled with chemistry we've never seen anywhere else. And Cassini is gone. 20 years of construction, planning, and operation, all ending in a controlled suicide into Saturn's atmosphere, so that the next mission could go to Enceladus without contaminating it first. The probe's final transmissions are sitting in NASA archives, the last few seconds of data from a spacecraft that had been our eyes at Saturn for an entire generation. Some of it is still being analyzed. The mission's official scientific output continues even now, papers being published every year, discoveries being teased out of data that was collected before some of the current graduate students were born. We didn't just touch Saturn, we lived there for a while, We learned what we could, and we left behind a mission so successful that it changed what the next decade of space exploration will look like. The question isn't whether we'll find life beyond Earth. The question is whether we already know where to look and how soon we'll have the equipment to confirm it. Cassini's legacy isn't just the photos and the data. It's the certainty that we now know which specific places in our solar system are worth the trip. Enceladus is one. Titan is another. Both are at Saturn. Both were unknown as serious targets until Cassini got close enough to see what was really happening. A beautiful ringed planet with a violent heart, generating a magnetic field that defies physics, surrounded by 274 moons, at least 2 of which may be hosting life right now in oceans we can't see. That's the Saturn we know after 20 years of NASA touching it directly. We sent a robot to a place nearly 1 billion miles away, and it spent 13 years there before we destroyed it. And the more we look at what it sent back, the more we realize Saturn was never really about Saturn at all. It was about everything we're still going to find. Thanks for watching, and I'll see you in the next one.